Thank you all for joining us for today's data visualization workshop. Joining us today is Hallie Burns from the library, so I'm just going to hand it over to her to get us started. Thank you.
Thank you so much. Before we get started, I just want to make sure, can everyone hear me okay? Wonderful. Thank you so much. So just letting everyone know, I do have chat open, so if you have any questions at any time, please feel free to let me know. Also feel free to just stop me. It's more of a conversation, a back and forth. So, hello everyone. My name is Hallie Burns. I am the data librarian and instructor. I've been here at UNLV just over a year. And previously I came from the University of Illinois, where I studied data management and data curation. So just to let everyone know that currently here at the libraries, we are doing virtual consultations. So consultations for data services, typically with me, would include anything to do with data management, data manipulation, data processing, visualization, as well as some introductory coding questions that you might have. So there we go. To start us off today, I just want to go over our learning objectives. So today we are going to discuss various methods of visualization and learn to assess visualizations. We are going to identify when visualizations are being misleading, and we are going to recognize data visualization tools that are free for use online. This is very much an introductory workshop, so we are not going to be broaching the actual subject of beginning your own visualizations or working on coding involved in it. So to get us started, I just want to ask you to take a minute and think about, write down, feel free to answer in chat if you would like. What is data visualization to you? What does it mean to you? When might you use visualization? Infographics, absolutely. Explaining statistics, yes. A visual way to convey relationships among data points, absolutely. You think about coding? To present data, these are great answers. Just gonna give it a second more to simplify. Absolutely, yes. Defining data in a more meaningful way and to show relationships, yes. Great, so it sounds like you all have a really good idea of what data visualization might be. So before we're going to get into the nitty-gritty of data visualization, I just want to talk about data. So data itself is defined as factual information, such as measurements or statistics, used as a basis for reasoning, discussion, or calculation. So this means that data can be a lot of different things. So this can be survey responses, code, measurements, recordings. If you work in the digital humanities, it might mean corpora of text or lexicons. So this means that you can work with a lot of different things, even coordinates. And because there are a lot of different types of data, there are so many ways of visually representing it. Because data is defined as factual, can we always trust the data that we see? Asking you as a group, can we always trust the data that we see? No. Why is that? Garbage in, garbage out, absolutely. Could be biased. Data can be manipulated. Yes. Wonderful. Great. So data itself can be used in a lot of different ways. It can inform how we react to different situations on large scale, but also it can be used to prevent or predict. So for instance, we frequently see data in the news, such as COVID hospital data, and it can inform whether, for instance, we might want to open up shop or whether we want to stay home. So it can inform how to address things on a small scale, such as whether you should wear a jacket or if your allergies might be bad. But it's also important to keep in mind, as many of you have said, that falsifying data or extrapolating inaccurate information can occur. So we need to view data as well as the visualizations that come from it with a critical eye. So as we said before, hopefully, I don't know if this chat box is blocking that, but data visualization is the graphical representation of information and data. So by using visual elements like charts, graphs, and maps, data visualization tools provide an accessible way to see and understand trends, outliers, and patterns. So what's really important here with that statement is the idea of accessibility and that idea of patterns and relationships. So visualizations are meant to inform, they're meant to convey information, preferably to a user in a way that's quick and a way that is easier to comprehend. So this means breaking down potentially difficult concepts in ways that can be introduced or taken in bite-sized pieces, ways that other people can see relationships or others might be able to point out exactly what you want them to see. Come on, there we go. So there's a lot of different times that we see visualizations every day. This doesn't necessarily have to be scientific visualizations. As someone mentioned earlier, infographics are very common. So different graphic elements, such as your phone battery, that in itself can be a visualization to show you how much you have left. City maps to show you where you're located or where other things are in relationship to each other, or even road signs to convey where you should turn or what roads you should not go down. So can anyone think of any other kinds of visualizations that you might see day to day, data-wise? Gas prices, weather icons, yeah, absolutely. Air pollution, the stock market. So we are going to take a look at some visualizations that you might see fairly regularly, whether in the news, online, but take a look at them with a bit more critical of an eye. So keeping in mind that not all visualizations accurately display information, what might you say is incorrect or misleading about the graph on the screen right now? The relationship, what's represented? Okay, yeah. The increasing trend, you have no idea what the axes represent. Absolutely. Missing units, definitely. So something that's very common with misleading data visualizations, and you can see it on here, as many of you said, missing units, absolutely. Not mentioning what the axes represent, absolutely. Here, something specific is happening in the y-axis. where if you look down at the bottom where the 0, 0 usually is, instead it's starting at 9100. So this is what's called truncated graphs, meaning that it's going to start at a higher place so that it can show this trend to make it look like there's a larger difference happening. So another example of this would be this next slide here, where it looks like there's a huge difference between these two figures. And this is something that was, for instance, shown on a news channel several years ago. And as you can see, this 108.6 million looks a lot larger than 101.7 million. But if this axis was really starting at 0, 0, the changes in those two very large numbers would not look as drastic as they might appear in this case. So this next graph, once again, it does not have any items that say what different figures represent, but can you tell me what might be misleading about the graph specifically on the left? No percentages, the depth, absolutely. The depth, no percentages. Item C looks important because it's jolting out, yes. And C appears as large as item A, absolutely. Because these two, as you have pointed out, because these two graphs, one moment, please. Apologies for that, everyone. I have scorpions in my apartment. So what's really important here about these two graphs is that the way it is centered on this screen. So as you can see, item D is pushed out quite a bit more. It's pushed to the front, so that makes it so that it looks more important. It looks like there's more items being shown in the visualization here on this screen. And as several have said, because item C is jutting out, it looks like that is the most important item here. And it also looks as though it might have the exact same amount as item A. So something like this graph, what might you say is misleading about looking at a graph like this? Where it came from? Okay. Absolutely. So if you look over at this area right here, as in it could have started out very high or very low. Yes. Yes, absolutely. So because this is only a 3-month view of this graph, it's really hard to see where it comes from and where it's going to. This is just a very small snapshot of the elements on the screen and does not entirely show the full story. So as it says, 3-month trend in the month is not. Yes, absolutely. So if you're looking to represent this maybe in a fuller manner, this actually shows the maximum amount of everything that's there. So another type of misleading data visualization is election maps. We've seen many of these in the news, specifically over the past few months. And I want to know, when looking at this kind of election map, what is misleading about this? What might not be accurate or might not tell the full story? Red states and population. 80% Dems have the same color as 51% Dems. Yep. The map doesn't indicate what blue states represent. Absolutely, it does not. Or the red states, no. So larger states have smaller populations. Yes, absolutely. And it's very limited information. Number of electoral votes, red and blue depends on counties. Yes. So election maps themselves are very difficult to display in a way that's telling the full story. As many of you have pointed out here, seeing red and blue only necessarily means something if you know what it means in the context of the American political system. So if you showed this to someone at a different country, they may not necessarily understand the background there. So it's important, as several have said, to have some kind of legend on your map to say this color means this and this color means that. Election maps are particularly difficult because, as several of you have said, different places in a state vote different ways. So the way that we might vote down here in Clark County is not the same that they might necessarily vote up in the, I can't remember directions, up in the northern part of the state. So by saying that the entirety of the state of Nevada is blue is really just an oversimplification. It's a generalization. And while this is not necessarily incorrect, it definitely doesn't tell the entire story that you might have there. We're going to skip over that one, and let's take a look at these two graphs. Now, what I want to know is, looking at these two graphs, which one might be conveying the data properly? Which one conveys the information better than the other one? Do you think the bar chart is better, or do you think the pie graph is better? The bar chart. Bar. Bar. And why might you say the bar chart? Why is the bar chart better? Nope, it still isn't great. And it does not tell us the years, absolutely. It shows the progress, though. It does start at 0. It's comparing, and the pie chart is showing proportions, absolutely. It's more exact. Great. So you all really got to it there, is that the pie chart is really showing something out of a proportion. It's out of 100%. And this isn't something that can necessarily be valued in that way. It's supposed to compare rather than show that kind of proportion. So as we've seen, there's a lot of different ways to mislead when it comes to data and visualizations. A lot of popular misleading ways are truncated graphs, as we saw when graphs do not start at the 0, 0 mark. When you're distorting the perspective or even distorting the y-axis, so you're making something look smaller than it needs to be or larger than it should be so that your eye draws attention to it. If you're being selective about your data or overgeneralizing your data, it might not tell the whole story. And then it's also important to keep in mind that not all graph formats are right for all types of data. Intent is very important, which we will be talking about next. Oh, first we're going to talk just really quickly. There's a few sites that display visualizations, just if you want to take a look. Data is Ugly, a subreddit, is sometimes fun, definitely wacky to look at, and it usually shows a lot of different popular, very bad data visualizations that you can see out there. And Data is Beautiful does the exact opposite. So now that you know how data can be misleading, let's talk about how to build effective visualizations. So there's a couple of things to keep in mind. You want to know your data because knowing your data helps you to identify errors, inconsistencies, and unique properties. So it also helps you to identify exactly what kind of visualization is best for your purposes. If you are working with a lot of coordinates, it might be that you want to use a map. If you're working with a lot of different textual data, maybe a word cloud is something that you want to keep in mind for. So just get an idea of what kind of data you have, what the data type is, how much data you have, and it might help to inform a little bit more about where you can go with that. Another thing to keep in mind is exploration and analysis. So primary visualizations can help you better understand the trends and explore varying hypotheses in the data itself. So visualizing your data, as we've said, can be an accessible way to present your findings at the conclusion of a research project. But it's also a way, particularly with preliminary visualizations, to help you understand trends within the data and explore varying hypotheses. So without that initial visualization, it might not have been clear from just that raw original data that you have that something might be happening behind the scenes. So for instance, if you're just looking at a chart that has a whole bunch of years and a whole bunch of numbers next to it, you're not necessarily going to see any kind of trend there. You're just looking at a bunch of numbers. But when you put that in a graph of some sort, when you play around with it to see, to explore within it really, to see what kind of relationships might exist, that's when you start to notice those patterns and might be able to explore different hypotheses. And then you also need to keep in mind to know your audience. So what kind of visualization you should create. So this means not just knowing who you're creating it for, but also why you are creating a visualization. So you don't need to visualize something just for the sake of having something visualized. It can mean something and it's meant to convey some kind of story. So knowing your audience tells you a little bit more about what kind of visualization might communicate these ideas better. So for instance, a scientific visualization, something ecologically based or something with scans might not be the best audience for, or might have a different purpose than, say, the battery bar on your phone. So when you're creating a visualization, one of the first things you want to think about is, what is your goal? What do you want people to get from the visualization that you've created? Do you want to inform or convey important messages? So when you are looking to inform, typically there's text that stands out. There's more icons. You see this a lot with infographics. Do you want to compare, so show similarities or differences? So things like the pie chart, the bar graphs. Do you want to show change? So things like timelines. Do you want to show an organizational structure, so a hierarchy? Or do you want to reveal relationships, so through things like scatter plots? But your goal can also be this idea of exploration, just to have the reader take a look at the data and discover insights for themselves. Once you have an idea of your goal, It's important to keep in mind what kind of data you have, because once again, this can help inform the best type of visualization for your purposes. So if you have categorical data, which is data that can be divided into groups, so this could be educational level, sex, race, things like that, that maybe could go with a bar graph, perhaps, depending on what you want to do with it. If you're looking for exploration and analysis samples, so data that can take any value within a range, you might be looking at height or time or length. And then if you're looking at univariate, bivariate, or multivariate, you might be looking more at temperatures, or correlations between things. So like temperatures and ice cream sales, or this could also include the idea of hierarchy. And then just once again, for univariate data, you're seeing a lot more of that comparisons, so your bar graphs, your pie charts. For bivariate, you're seeing a little bit more scatter plots, and for multivariate, you're seeing more of those relationship-y type graphs. So now I just want to quickly talk about different types of visualization methods as well as popular tools. So as was mentioned before, there's many different ways to visualize. So these are just a couple of examples. But infographics are visual representations of data, such as charts or images with minimal text, and they're meant to communicate or inform people quickly and with ease. So those, for instance, are frequently like posters that you might see around campus, or different types of infographics might include, as I've said several times, the battery bar on your phone. There's geospatial data, so working with maps. So this could also include the idea of interactive timelines or geo-based exhibits for digital storytelling. And then there's also the visualization methods and the analysis methods about network analysis and network graphs, which typically show relationships using edges and nodes. So using lines, which represent the relationships, and then those little circles, which are usually the subjects or nodes. There are a number of free tools that you can get either with your UNLV email address or just on your own. These are very popular tools and do a lot of different things, or we do have access to many of these at the UNLV libraries. So all of these software are available for download and for use in your browser. Some do require the creation of an account, though. So Tableau, it's very popular specifically for data exploration or just your standard data analysis. And Tableau provides a free year download for students as long as you have a university email address. So that would be Tableau Student, or you could always get something called Tableau Public, which is basically the same as Tableau, just when you go to save things, it has to be saved on a public server rather than a private one. There's Canva and Venngage. These are very popular for infographics. Canva and Venngage, you can create posters, infographics, as I said, but also Twitter designs for Instagram, any kind of small snapshots or posters, things like that. QGIS and story maps are free to use in relation to geospatial data. Story maps are a bit more for digital storytelling and geo-based exhibits, while QGIS is essentially the free version of what ArcGIS might be. Gephi and Cytoscape are two different types of network analysis tools, both free. And Voyant is specifically used for text analysis and has many applications there. So in addition to these specific tools that we have, there's also programming languages such as Python or R that are available for download. And so popular packages for Python include matplotlib, that's very popular for visualization, as well as Seaborn. And for R, ggplot is also a very popular package for visualizations. So if you have any questions about those, please let me know. I'm just going to get out of the slideshow really quick and just show you a resource that we have once that thing goes away. Please, there we go. So something that we have on the university library pages is something called a library guide. This is the guide for data visualization. It has a number of different connected guides, as well as this side navigation bar here, which gives further information about each of these items. So for instance, there's a Visualization 101, which talks about things to keep in mind, why you might want to visualize, as well as any workshop materials that might be precedent. There's geospatial data, which just gives a lot of different options as far as your geo-based exhibits. What's particularly useful are the online application and resources. So these are all free and all different types of visualization software that you can get in the browser. And then figuring out where the software is on campus. So this will show where ArcGIS, SAS, and SPSS and Stata are, and in which labs on campus. So just take a look at that. For instance, it also has some extra information, so books that you can look at, as well as any software that might be useful. So that is just a look at that. So I just want to show a quick look at one of those options. I am going to put the link to this guide in the chat in case anyone needs it. But what we are going to look at really quickly is an option for just your basic visualization. It's something called raw graphs. I will be putting this link in the chat as well. Just looking at the screen, it does look a little bit sketchy, I know. It is not, it's actually a really useful website. So raw graphs is essentially a way for you to input data to just get a really quick idea of what kind of visualizations might be best. So once you open raw graphs, you go to this main screen and you would just go to use it now, which will open another pop-up window. Here you have the option to paste data from another application. So you can paste it from a CSV or an Excel file or from Google Sheets if you wanted to. You could also choose to just upload a file or get something from a URL. So if you had something in Google Sheets, you could just attach the URL here. What I particularly like about raw graphs is that they have samples, so you can play around and just get an idea of how it works. So today I'm just going to show you really quickly just kind of how it works using one of these samples. So if we look at here, we're just going to take a look at this orchestra one. And once you click it, it loads the data. It will bring up your data in something that looks like this, which is not, it is structured, but it doesn't look structured. And here in this upper right-hand corner, you can click this little grid button, and that will make it so that it looks more like a spreadsheet that we're typically used to seeing. So as we can see here, we can just really quickly explore our data. We have a couple of textual elements as well as a number. We can see the orchestra types. So there's classical, early romantic, so we can see there's categories in here. And this group also has categories, so woodwind, strings, brass, and then instrument. So because we know when we uploaded the sample that it is a hierarchy, once we scroll down, we can see here, which is why I like raw graphs, that there's a lot of different options here for what you might want to choose to visualize. And for each of these options, you can click on it and it will tell you both the name of the option, what type of data it might be best for, as well as a brief description. Let me just get some water. So for instance, the scatter plot is more for the dispersion. It's more for comparing and contrasting. The hierarchy is maybe not the best bet for something like this. But if we continue to scroll down, we can see that there are several hierarchy options, such as the circular dendrogram, the cluster dendrogram, and then the circle packing. So what I'm just going to do really quickly is click on the circle packing. And when I click on this, it's going to pull up this little bar in the left-hand side that just says exactly what it is and what the design is based on. To actually fill out your graph, you continue to scroll down. And this is a drag and drop option called Map Your Dimensions. So here you can literally drag and drop the different elements and see what happens. So, for instance, I have just dragged group and orchestra type together, and if I continue to scroll down, this is what shows up. So this is what happens if I grouped orchestra type and that. I'm going to get rid of group by pressing that little X there. So as we can see, modern orchestra, early romantic, late romantic, and classical orchestra, once again, this only tells us so much. So we can continue to play with the different items here. So let's say I'm just going to get rid of that and I'm going to put hierarchy as instrument. I'm going to make the orchestra type the color and the size the number. So what this is going to do is each individual item is a separate instrument. The type of orchestra that it is represented in is going to be a different color. And then the number, so how many times it's represented in our data set. If it's bigger, it's represented more. If it's smaller, it's represented less. So we can see here why this might be potentially useful for a very quick, for getting a quick idea as far as a data visualization. And you can continue to drag and drop and play in different ways to see how things might work. When you're done with it, you can save this to your computer as I continue to scroll down. Or what's very cool about this is that you can embed it in your own website. So you can take this SVG code and embed that into an HTML. So I just want to take maybe 5 to 10 minutes. And I would like you all, if you are able, to go back up to the top. I will put that link in chat again and go to try our samples and then just take a look at this movie dispersions one. I want you to take a look at the different data that's included in here and then play around a little bit, see what type of plot might be best for this and what you might want to compare, what questions you might want to answer looking at this data. So we're going to take a couple of minutes now, and I will put the link back in chat. And I will set a timer, but please let me know if you have any questions. And then we're just going to come back and talk about it very briefly. So we're just going to give it about 2 more minutes. Okay. So feel free to either type in chat, unmute, or just message me privately if you would like. I'm just curious, taking a look here. What kinds of questions, what kind of comparisons did you make here? What did you want to visualize looking at this data set? ROI stats by genre. Wonderful. Cool. Genre to box office. Yes. Production and money. Yeah, when I was playing around with this, I took a look at the production budget as well as the box office. So looking at the data set that we have here, what kinds of visualizations in this area did you try? Which one worked best for you, or which one did you primarily focus on? Pie chart. Okay. High and bar. Okay. So my last question for this is what do you think, what do you wish this website could do better? What is it lacking? What do you want to be able to do with it that it can't? No way to compute stats, exactly. No line graph, absolutely. So while something like this is very good for getting an idea, for playing around with your data initially, exploring it, getting an idea of what's involved or what might be the best option, I will have to get back to you on that question. I'm not sure if you can upload SPSS, but I will find out in a few minutes. So while these might give you an idea of what your first steps might be, it's limited in the visualization capabilities that it has. So it gives you an idea, but you'd want to take this and then go forward from this at a later point. And then go into one of your more complex or more nuanced ones, such as Tableau or a coding language that you might want to utilize. So where is it? Okay. So I'm just going to go and do this really quick concluding slide and just say that, okay, the site says you can upload TSV, CSV, DSV, JSON, and Excel. Okay, so it might not take SPSS as a file format, but if there's a way to convert the data that you have there into some kind of Excel or tabular spreadsheet, so that would primarily work with that, with tabular data. So just in conclusion, data visualizations are effective ways to communicate information to your audience. Visualizations can mislead or sometimes outright lie, so be purposeful with the selections that you make and keep your eye open. Sometimes less is more. Be critical. Different types of data fit best with different types of visualizations. And there are many different methods and different ways of visualizing your data for what works best for you. As I said before, we here at the libraries are here to help, and I'm happy to take any questions at this time. Yes. And I will share these files, this slideshow with everyone afterwards.
So if nobody else has any questions, we will wrap up. Oh, looks like there's a question.
What is the final goal? So the final goal is just the idea of exploration. So if you wanted to have the user explore for themselves. Do we have access to a program called eViews? I would have to take a look at that. Let me stop sharing my screen for a moment. I am not certain, but I will take a look and find out what I can and get back to you. I will shoot you an email sometime before the end of this week and find out. Yeah, you're welcome to contact me for any kind of visualization questions. I'm limited in what I can provide, but we're here to consult. We're here to help advise in whatever way we can. So yes, feel free to contact me. Yeah. Let me find the page really quick. So I'm going to put in chat the page for data services. This talks about everything that we offer, as well as a list of our previous workshops. This coming semester, we're going to be offering 5 different workshops. So an introduction to data management, reproducible research, humanities data curation, data cleaning, and text analysis are the things that we're going to be offering this coming semester. But that link there will also tell you the different services that we offer as far as consultations goes. I'm primary contact there, so happy to answer any questions. Do we have a free download for Stata? That I'm not sure of either. I know that we can get them. I know that we have access to them on the library computers, but that might be a question for IT. Scrolling down the list. Yeah, I would contact IT. They do have a list of software that they do have access to, but I know not all of these are available for free. Oh, yeah, I'm sorry about that. I had asked them to come later, and there we are, but thank you.
All right. Well, thank you so much for sharing your time with us today. We really appreciate it.
Thank you for having me, and sorry for the interruption.
Oh, no, it's all good. Thank you so much. All right, everyone. We'll see you at the next workshop.
Thanks. Bye.